third presenter is Joshua Oliver from the Faculty of Arts and Science. Joshua is pursuing a Master of Science in Biology. His thesis title is Characterization and Functional Assessment of Saccharomyces cerevisiae-derived exosomes for Next-Gen Therapeutics. And his 3-minute thesis title is They Shall Pass. Good luck, Joshua.
What a haunting situation that must be, to look at a photograph of a young, beautiful, smiling person and be reminded daily that that was you at one point in time. Now that is the reality of Alzheimer's disease. Alzheimer's affects 50 million people worldwide, and this number is expected to rise to 152 million people by the year 2050. It is a challenging disease to treat because of something called the blood-brain barrier, the border between our bloodstream and our brain, which limits entry of therapeutic drugs into our brain. However, researchers might have found a herd of Trojan horses that can revolutionize how we treat this disease. They are called exosomes. Exosomes are these nano-sized messengers which establish lines of communication between our cells. Similar to how we exchange words with one another, exosomes are the words spoken by our cells. Now, because of their small size, they can cross the blood-brain barrier and be used to deliver drugs to the brain on a nano scale. However, the first step that must be taken is to design a strategy to collect these exosomes from our cells. Now, progress has been made thus far, but still there's no universal way to collect these exosomes from our cells, and this is what limits their therapeutic potential. In my research, I study yeast, an organism that is commonly used to make bread, but also communicates using these exosomes. But why yeast? Well, yeast is functionally versatile and cheap, making it both a biologically and economically attractive model to study for therapeutic applications. The research question I asked myself is, how can I design yeast exosomes to function as a drug delivery system? As a biologist, what I do is I collect exosomes from yeast and study their size, structure, and identify what's inside them. So far, I have successfully designed, tested, and confirmed a strategy to reproducibly collect exosomes from yeast. The next step my lab will take will be to package drugs into them and assess their ability to target and release drugs to human cells. Now, if we are successful, returning to the treatment of Alzheimer's disease, exosomes will symbolically represent a company of Trojan horses, all with the ability to sneak past the blood-brain barrier and tactically release the drug within the brain to combat the disease. This form of drug delivery will revitalize the memories embedded in timeless photographs and have those very photographs greeted with a youthful smile. Thank you for your time.